Nuclear energy is energy in the nucleus or core of an atom. Atoms are tiny particles that make up every object in the universe. There is enormous energy in the bonds that hold atoms together. Nuclear energy can be used to make electricity because energy is essential for sustainable economic growth and improved human welfare. Nuclear energy provides access to clean, reliable and affordable energy, mitigating the negative impacts of climate change. It is a significant part of the world energy mix and its use is expected to grow in the coming decades. Nuclear energy, also called atomic energy, energy that is released in significant amounts in processes that affect atomic nuclei, the dense cores of atoms. It is distinct from the energy of other atomic phenomena such as ordinary chemical reaction, which involve only the orbital electrons of atoms. Atoms are tiny units that make up all matter in the universe, and energy is that what holds the nucleus together. There is a huge amount of energy in an atom's dense nucleus. In fact, the power that holds the nucleus together is officially called the strong force. Nuclear energy can be used to create electricity, but it must first be released from the atom. It can be released from atoms in two ways: nuclear fusion and nuclear fission. The first way, nuclear fusion, is the process by which nuclear reaction between lighter elements form heavier elements. In cases where the interacting nuclei belong to elements with low atomic numbers, for example hydrogen or its isotope deuterium and tritium, substantial amounts of energy are released. This is how the sun produces energy. The vast energy potential of nuclear fusion was first exploited in thermonuclear weapons or hydrogen bombs, which were developed in the decade of immediately following World War II. Another method to release energy from the atoms is nuclear fission. In nuclear fission, the nucleus of an atom, such as that of uranium or plutonium, breaks up into two lighter nuclei of roughly equal mass. In the fission process, a large quantity of energy is released, radioactive products are formed, and several neutrons are emitted. These neutrons can induce fission in a nearby nucleus of fissionable material and release more neutrons that can repeat the sequence, causing a chain reaction in which a large number of nuclei undergo fission and enormous amount of energy is released. Now let's go to the nuclear reactor, which gives us clean energy through nuclear fission process. A nuclear reactor or power plant is a series of machines that can control nuclear fission to produce electricity. The fuel that most widely used to produce nuclear energy is pellets of the element uranium. That's because uranium atoms split apart relatively easily. Uranium is also a very common element found in rocks all over the world. However, the specific type of uranium used to produce nuclear energy, called uranium-235, is rare. Uranium-235 makes up less than 1% of the uranium in the world. A typical nuclear reactor uses about 200 tons of uranium every year. Complex processes allow some uranium and plutonium to be re-enriched or recycled. This reduces the amount of mining, extracting, and processing that needs to be done. In nuclear reactor, atoms of uranium are forced to break apart. As they split, the atoms release tiny particles called fission products like few neutrons, heat energy, and gamma rays. Fission products cause other uranium atoms to split, starting a chain reaction. The energy released from this chain reaction creates heat. The heat created by nuclear fission warms the reactor's cooling agent. A cooling agent is usually water, but some nuclear reactors use liquid metal or molten salt. It is used to remove heat from the nuclear reactor core and transfer it to electric generators and turbines. The cooling agent heated by nuclear fission produces a steam. The steam turns turbine or wheels turned by a flowing current. The turbines drive generators or engines that create electricity. Rods of material called nuclear poison can adjust how much electricity is produced. Nuclear poisons are materials such as a type of the element xenon that absorbs some of the fission products created by nuclear fission. The more rods of nuclear poison that are present during the chain reaction, the slower and more controlled the reaction will be. Removing the rods will allow a strong chain reaction and create more electricity. Nuclear energy and its effect on environment. Nuclear energy produces electricity that can be used to power homes, schools, businesses, and hospitals. Building nuclear reactors requires a high level of technology, and only the countries that have signed the Nuclear Non-Proliferation Treaty can get the uranium or plutonium that is required. For these reasons, most nuclear power plants are located in the developed world. Nuclear power plants produce renewable and clean energy. They do not pollute the air or release greenhouse gases. They can be built in urban or rural areas and do not radically alter the environment around them. The steam powering the turbines and generators is ultimately recycled. It is cooled down in a separate structure called a cooling water. The steam turns back into water and can be used again to produce more electricity. Excess steam is simply recycled into the atmosphere where it does little harm as clean water. However, the byproduct of nuclear energy is radioactive material. Radioactive material is a collection of unstable atomic nuclei. These nuclei lose their energy and can affect many materials around them, including organisms and environment. Radioactive waste is long-lasting. Materials like clothes and tools can stay radioactive for thousands of years. Used fuel and rods of nuclear poison are extremely radioactive, which must be stored in special water containers. Water cools the fuel and insulates the outside from contact with the radioactivity. Some nuclear plants store their used fuel in dry storage tanks above ground. Radioactive material can be extremely toxic, causing burns and increase the risk for cancers, blood disease, and bone decay. Future of nuclear energy. Chicago Pile 1 was the world's first artificial reactor. On December 2, 1942, the first human-made self-sustaining nuclear chain reaction was initiated in Chicago Pile 1 during an experiment led by Enrico Fermi. Since then, about 443 nuclear reactors have been built all over the world. The United States has more than 100 reactors, although it creates most of its electricity from fossil fuels and hydroelectric energy. Nuclear reactors use fission to produce energy. The sun, for instance, is constantly undergoing nuclear fusion as hydrogen atoms fuse to form helium. Because all life on our planet depends on the sun, you could say that nuclear fusion makes life on Earth possible. Nuclear power plants do not have the capability to safely and reliably produce energy from nuclear fusion. It's not clear whether the process will ever be an option for produce electricity. Nuclear engineers are researching nuclear fusion, however, because the process will likely be safe and cost-effective.